Hi, today I'm going to be presenting 2018 AMC problem number 24. In the cube A, B, C, D, E, F, G, H, with opposite vertices C and E, J and I, are the midpoints of edges FB and HD, respectively. Let R be the ratio of the area of the cross-section EGCI to the area of one of the faces of the cube. What is R squared? I read through this diagram, but a bit bigger. And this EGCI, the cross section, is a rhombus because CD is some side length, some consistent side length. DI is also some consistent side length. And we know that HI is equal to DI because we know I is a midpoint of HD. And that means I to one end of the segment is the same length as I to the other end of the segment. And we know that HE is the same as CD because it's a cube. And it's the same reason for the other two sides. And that means these two will be the same, and so will the other two. They'll be the same. So that means this is a rhombus. That's a good fact that we could use later. Let's call CD S for side length of cube. Let's call D, that means DA is also S. And EA is also S because it's a cube. So all the side lengths are the same. We know that the diagonal CA is S times the square root of 2 because this is 90 degrees, and that's what the Pythagorean theorem tells us, that S squared plus S squared square root is 2s is square root of 2s. So this side is square root of 2s, or S root 2. This height is S. So we can find the longest diagonal CE or EC by the Pythagorean theorem again, because we know that this over here is also a right angle. So the Pythagorean theorem can be used again. So that's S times the square root of 2 squared plus S squared is equal to 3S squared, because S root 2 squared can be written as S squared times root 2 squared, or square root of 2 squared, which is equal to S squared times 2, which is equal to 2S squared. We add S squared, we get 3S squared. So now you have to square root, because that's how we finish off the Pythagorean theorem. Square root 3s squared, we get root 3 times square root of s squared, because a property of square roots is that you can split up if it's multiplication or division, you can split it up into different square roots. So that is equal to square root of 3 times s, because the square root of s squared is just s, and square root of 3 times s is s root 3. So EC is s root 3. Let's clear out some of the other things because we don't need that anymore. Now we found that the diagonal is s root 3. Okay, now I to the midpoint of side GC is the same as S because CD was S, and I to GC is parallel to CD, and DI is the same as C to the midpoint of GC. So that means this right over here, the thing that I'm highlighting with the marker, is a rectangle. And that means that CD should be the same as this top side length. That means I to the midpoint of GC, that's S also. Same with here to J, that's also S. So we have this is S and this is S. JI, we can use the Pythagorean theorem once again, is S times the square root of 2, because that's what the Pythagorean theorem tells us. Let's clear out S, these two side lengths again, we don't need those anymore. So now we have the rhombus. And notice what these S root 3 and S root 2 are. They're diagonals of the rhombus. So now we have this rhombus right here. The diagonals of the rhombus are S root 2 and S root 3. So this side is S root 3 and this side is S root 2. We can do this two ways now. Find the area of the rhombus using the rhombus trick, which is this. S root 2 times S root 3 over 2, because the area of a rhombus is its two diagonals multiplied over 2, which is S squared root 6 over 2. Or we can do it by adding the four triangles here. So we'll fade out these two and these two text boxes. Now we're left with this triangle. The side lengths of this triangle are actually S root 3 over 2 and S root 2 over 2. S root 2 over 2 is this side. S root 3 over 2 is this side. Because this is actually the diagonal divide and cut into two parts because this and this are the same because this is the center of the rhombus. So this is s root 3 over 2 and this is s root 2 over 2. So now this is a triangle and this is the height of the triangle. S root 3 over 2 is the height of the triangle and s root 2 over 2 is the base of the triangle. So the area of this triangle is s root 2 over 2 times s root 3 over 2 over 2. But let's ignore that last over 2 currently. It might make things simpler. So that's s root 3 over 2 times s root 2 over 2, which is s squared root 6 over 4. We also have to divide by 2, but let's not consider that yet. We can always do that later because multiplication is commutative. So we can divide by 2 later. First, let's do this. Since there are 4 triangles in this rhombus, we anyways have to multiply by 4 to find the total area of the rhombus, right? Because these triangles are congruent. So first let's multiply by 4. If we multiply it by 4, s squared root 6 over 4 times 4, the 4's will cancel out, and we're just going to be left with s squared root 6. Now let's divide by 2 as we skipped earlier. So we're left with s squared root 6 over 2, right? So now we found the area of the rhombus. That's the side length of the cube right here, GH or say CD or any of the other side lengths. In terms of the side length of the cube, the area of this rhombus is s squared root 6 over 2. So now we have to divide the areas of the rhombus and the square to find the ratio. Since CD is one of the side length of the square, one of the faces of the square of the cube, we can get that the area of this square, GHCD, or any of the other squares, is s squared, because that's how you find the area of a square. So we divide area of the rhombus divided by the area of the square. That's s squared root 6 over 2 over s squared. That's the same as s squared root 6 over 2 times 1 over s squared. The two s squares cancel out, and we're just left with root 6 times 1 over 2, which is root 6 over 2. And r is the ratio of the cross-section EGCI, which is a rhombus, to the area of one of the faces of the cube, right? So now we just got r, because it's the ratio of the rhombus and the square. And that's what division tells us. So r is root 6 over 2. Now all we got to do is square it. That's r. So now r squared is 6 over 4 because if we square, then that we can do square root of 6 squared over 2 squared. The square root of 6 squared is 6, and 2 squared is 4. So r squared is 6 over 4, which can be written as 3 over 2. So the answer is C.